Before we try to multiply two polynomials, let's try multiplying a monomial and a polynomial. We already know how to multiply monomials. That's just a matter of rearranging the factors. Multiplying a monomial with a polynomial is just an application of the distributive property together with the exponent rules. And we can think of this, if we're thinking about arithmetic with numbers, we can think about this as like multiplying a multi-digit number by a one-digit number, which is something that we need to develop before we can try to multiply two numbers with many digits. So here again, we're going to go through this process justifying every step first. After copying the given polynomial, our first step is to apply the distributive property. So now each term has been multiplied by that 3x squared y. And the next thing we want to do is use the commutative property of multiplication to rearrange the terms. So within each term, I'm going to put the numbers first, then the x's, then the y's. Numbers first, then the x's, then the y's. Numbers first, then the x's, then the y's. So within each term, I've used the commutative property of multiplication to put factors of the same type next to each other. Next, I'm going to multiply numbers and apply the exponent rules. So 3 times 4, I have 12. X squared times x squared, that's x to the 2 plus 2. And then there's only one y there. 3 times 6 is 18. X squared times x squared. So within each term, we're going to rearrange to put the numbers first. So 3 times 4. Then the x's. X squared times x squared. Then the y's. Just a single y in that first term. Numbers first. 3 times 6. Then the x's. X squared times x. Then the y's. Y times y. Numbers first. 3 times 3. Then the x's, just a single x squared here. Then the y's, y times y squared. So what we've just done is just used the commutative property of multiplication to put factors of the same type next to each other. Next, we're going to go through, we'll multiply the numbers, and we'll apply the exponent rules. So 3 times 4 is 12. X squared times x squared, that'll be x to the 2 plus 2. And then we just have y. Minus 3 times 6 is 18. X squared times x, that'll be x to the 2 plus 1. Y times y, that's just two copies of y added together. That's just y squared. Plus 3 times 3 is 9. X squared. Y times y squared, that'll be y to the 1 plus 2. And then our last step is to just do the addition and the exponents. So we'll have 12 x to the 4th y minus 16 x to the 3rd y squared plus 9 x squared y to the 3rd. So again, this is with all of the gory details written out. We will typically not write out all of these details, but this is what's happening. And this is why, for example, the powers of x combine in the way that they do. Let's see how we might typically write out this problem, or a problem of this kind. So after copying the given expression, We might write out the step where we apply the distributive property. So we've got negative 2x times negative x squared plus negative 2x times 7x plus negative 2x times negative 3. Then we'll just go through and multiply. So negative 2 times negative 1 is positive 2. X times x squared, that's going to be x to the 2 plus 1 is x to the third. Negative 2 times negative 7 is negative 14. X times x is x squared. Negative 2 times negative 3 is positive 6. And then there's just an x. So we might not write out the details of the monomial multiplication, of the part where we multiply the numbers and apply the exponent rules.